Let us start the first chapter, basic concepts of thermodynamics. Objectives of the chapter: first is to identify the unique vocabulary. There are various terms, and we can say vocabulary related to thermodynamics. We have to understand those various terms and what are their precise definitions. Then the second objective of this chapter is to explain the basic concepts of thermodynamics, like what is system, what is state, what is equilibrium process, and what is cycle. The first term is what is thermodynamics. Thermodynamics is the science of energy. We are going to deal with various forms of energy in thermodynamics. Thermodynamics consists of two words, two terms. First one is therm, second is dynamics. The meaning of therm is heat and meaning of dynamics is power. Now, one of the most fundamental law of nature is conservation of energy principle. Conservation of energy principle is the law of nature. Now, if we have some amount of energy in the form of input and we have some amount of energy in the form of output, their difference can be represented with the help of delta E, which is the stored energy or the energy going out. Energy, according to this law, which is the conservation of energy principle, according to this law, energy cannot be created or destroyed. It can only change forms. And this statement is also known as first law of thermodynamics. What does it mean practically? If a rock, suppose it is a piece of rock, it is falling off a cliff, what will happen? It picks up the speed. As a result, there will be a change of potential energy into the kinetic energy. At this position, kinetic energy will be zero and kinetic energy will increase in the downward direction and potential energy will decrease in the downward direction. Kinetic energy will increase and potential energy will decrease. There is a conversion of one form of energy, potential energy, into the form of kinetic energy. Then after that, there is another law which is known as the second law of thermodynamics. The second law of thermodynamics says that the energy has quality and quantity. And the actual process which is occurring over there is in the direction of decrease of quality, What it means? It means if we are going to consider a cup of coffee, there is a hot coffee into the cup and it is surrounded by a fluid or air which is at a lower temperature. It is a cup of coffee, there is a hot fluid inside the cup and it is surrounded by cold air which is at a low temperature. What will happen? There will be a change of energy. From the hot cup to the atmospheric air, which is the cool environment. We can say cool environment. Okay. Energy will transfer in the outward direction. Then thermodynamics can be of two types. First one is the classical thermodynamics, second is the statistical thermodynamics. What is the difference between these two types of thermodynamics? It is well known that a substance, it is composed of various molecules, or we can say there are particles inside the substance. The property of the substance naturally depend upon the behavior of these particles, the particle inside the substance. In case of a container, if it is filled with a gas, what will be the pressure inside the container? We don't need to understand the behavior of individual particles. It would be sufficient to attain a pressure gauge. The pressure gauge will be sufficient to note down the reading of the pressure. This macroscopic approach to study the thermodynamics does not require the knowledge of behavior of individual particles. And this type of thermodynamics is known as classical thermodynamics. In classical thermodynamics, we don't need to study the behavior of individual particles. But in case of statistical thermodynamics, It provides a direct and easy way to solve the engineering problems, a more elaborated approach, and it is based on average. It is based on average behavior of a large group of particles. If we are going to study the large group of particles instead of individual particle, then it is a statistical thermodynamics. Then it is a statistical thermodynamics. Application areas. What are the various application areas of thermodynamics? It is hard to imagine an area that does not relate to thermodynamics. What does it mean? I want to say that all activities in the nature involve some interaction between the energy and matter. So, thermodynamics is commonly encountered with many engineering systems and other aspects of life. And one does not to need go very far to see some application areas. And various application areas like thermodynamics is dealing with human body, and we find application areas, uh, ordinary household appliances and utensils available in our house like refrigeration, heaters, etc. Then thermodynamics is also used in aircraft and spacecraft, in automobiles, and thermodynamics is also used in thermal power plants, food processing industries, etc. Next is there are various terms like what is system and what is control volume. A system, it is defined as the quantity of the matter or a region in space, maybe a region in space or a quantity of matter, and that quantity of space or a region in space or a quantity of matter is chosen for study. The mass or region outside the mass or region outside the system is known as surrounding, and system and surrounding, they are separated by a boundary. The boundary may be real, it may be imaginary. The boundary is the contact surface shared by both the system and surrounding. It is the surrounding and it is the system, it is the contact surface. Mathematically speaking, boundary has zero thickness. It has zero thickness, and it can neither contain or any mass or occupy any volume. Boundary itself has no mass and itself has no volume because it is a very thin line which separates system and surrounding. There are three types of systems: closed system, open system, and isolated system. First one is the open system, or you can say, or sorry, closed system. In closed system, depending on whether a fixed mass or a fixed volume in space, which is chosen for study, a closed system, which is also known as a control mass, or which is also known as just system. Okay. In this case, no mass can cross its boundary, no mass can enter or leave the closed system. Suppose we have a cylinder piston arrangement. We have a cylinder piston arrangement. In the cylinder piston arrangement, if there is a gas and we are going to heat that gas, if m mass, which is equal to constant, there is no inlet and outlet for that mass for a particular process. In that case, no mass can cross the boundary of the system. But energy in the form of heat or work can cross the boundary. If as a special case, if there is a special case, even energy is not allowed. Let's say there is a special case, cylinder piston arrangement or any container, there is a gas inside the cylinder. Okay. Mass and energy both, they cannot cross the boundary, then it is known as isolated system. Then it is known as isolated system. And then open system. What is open system? It is also known as control volume. If the space selected or the region in space is selected properly, then we can say it is an open system or a control volume. What does it mean? I want to say that usually in engineering, most of the equipments or appliances, they are of open system. Mass flow, they involve mass flow. They involve mass flow such as compressor, turbine, nozzles. It is a diagram for nozzle. It has two boundaries. One boundary, here the boundary is real, and here the boundary is imaginary. In this case, mass enters into the system from left hand side and it goes out from the nozzle from right hand side. It involves mass, and a large number of engineering problems involves mass flow in and out of the system, and therefore they are modeled as control volume. Most of the engineering problems, they are modeled as control volume. As a example of we can say a water heater, a car radiator, a turbine, compressor, all involves mass flow and should be analyzed as a control volume. And control volume is also known as open system. In general, an arbitrary region in space, like we have selected a region and it is an arbitrary region and it is selected in space. In this case, we can say, and there is no concrete rule for selection of the control volume. How to select the control volume? There is no concrete rule for that. What we have to do, we have to choose the analysis in a much easier way.